Welcome students, let us discuss this question number 4. This question is from AP Calculus BC 2022 free response question. In this video, we are going to discuss question number 4. So the question is, an ice sculpture melts in such a way, there is an ice sculpture that is in a conical shape, and it is melting in such a way that it can be modeled as a cone that maintains a conical shape as it decreases in size. So this is in conical shape, this is made of ice. The radius of the base, base of cone is given by a twice differentiable function r. So its base radius, we can write its base radius, that is r. It's a variable because it is in melting condition, so this base radius is also variable. So this is a function of time, so we have written it r of t and it is given, this is twice differentiable. This is twice differentiable. This is little information, but its importance is very high. Okay, the radius of the base of the cone is given by a twice differentiable function r, where r of t, you know, where this is, why this is written in t, because this is a variable, is measured in centimeters. So r of t, radius, which is a function of time, and its unit is centimeter. Okay, so t is measured in days, so t, that is the time, it is measured in days. The table above gives selected values of r dash t. So we have given the values of r dash t, the rate of change of radius with respect to time for the time period 0 to t and less than 12 days. Of course, this is written in days, right? So this table is that this is days in time, days that represent time, and this is the r dash t, that is the differentiation of r, that is the rate of change of r with respect to time. So let us take the first question, first part, that is the part A. The part A is saying approximate r double dash 8.5 using the average rate of change of r dash over the interval 7 to 10. Okay, so we have to take average rate of change from 7 to 10, right? If we take the average of 7 and 10, 7 plus 10 divided by 2, we got 17 by 2, that is 8.5. That is written here. And what is r double dash? It is the rate of change of r dash t, or we can say slope of r dash t. So how we can take out this average? We can take r dash 10. So let us see. See, this is the average value of 7 and 10, right? But we will do not like this, r dash 7 plus r dash 10 divided by 2. This is wrong. This is absolutely wrong. We have to find, see, rate of change of r dash t. We have to find rate of change of r dash t at t is equal to 8.5. You know what is the rate of change? Rate of change is just like how we find the differentiation of any function, right? Geometrically, we find the slope. And how we can find slope? If there is a line having this point, let us suppose x2 comma y2, and this point having x1 comma y1. So how we can find slope? Slope is basically y2 minus y1 upon x2 minus x1. Like this, we can find the slope or differentiation. So we have to find rate of change of r dash t at 8.5. So we will do it here like this. We will write r dash 10 minus r dash 7 divided by 10 minus 7, right? Just like this. As we find the differentiation or slope, similarly we have to find r double dash t. So what it will be, r dash 10 is minus 3.8 minus r dash 7 is minus of 4.4 and whole divided by 3. After calculating it, we will get 0.6 divided by 3. Okay, and after calculating this, we will get 0.2 and its unit will be, see how we can find unit. Its value should be centimeter per day upon this is a day, right? R dash unit will be centimeter per day and this will be in days. So overall unit will be centimeter per day square. So the answer will be 0.2 centimeter per day square. So this was our first part. Let us see its second part. Its second part is, it is saying, is there a time t between 0 to 3, or we can say from 0 to 3, for which r dash t is minus of 6. Is there any time belonging from 0 to 3? We have to check this. Is there such time? So how we can check this? Let us see. We know RT is twice differentiable. It is given in question. It is twice differentiable. It means R dash T is defined and it should be continuous. Why? Because R dash T is also should be defined. Because it is twice differentiable, its differentiation is this, its differentiation should be this. For to be differentiable of R dash T, it must be continuous. So for to be differentiable R dash T, it should be continuous. So R dash T is continuous function. So let us see the values. R dash 0 is basically minus of 6.1. R dash 3 is minus of 5.0. This is written in our table, right? So let us visualize this. For better understanding, let us visualize this. This is 0 and this is 3. R dash 0, we are going to plot the graph of R dash T. Roughly approximation, only for your understanding. R dash 0 is minus 6.1. Let us suppose here minus 6.1, right? And R3 is minus 5.0. So R3 will be, let us suppose, like this, minus 5.0. And we know this function is continuous. And we know this function is continuous. How it is possible? How it will be like this? So it may be like this, kind of this. So it is continuous and it has to pass from minus 6.1 to minus 5.0. So can we say confidently that there will be some point minus of 6? Minus of 6 will be where? Minus of 6 will be like this. Here it will be minus of 6. Minus 6.1 will be here, minus of 6 will be here. And it is continuously, graph is continuously varying from minus 6.1 to minus 5.0. So there must be any variable, there must be any point here, this line between 0 to 3, at which its value will be minus 6. And this is known as intermediate value theorem. This is known as intermediate value theorem, or we can say IVT, right? So according to IVT, we can say there must be a point C lying between 0 to 3 for which R dash T value will be minus of 6. So I hope this part will be also clear. Let us see the next part. Next part is using a right Riemann sum with the 4 subinterval indicated to the table, approximate the value of this 0 to 12. We have to find integration 0 to 12 R dash of T dt. We have to use 4 subintervals. Let us see the table. We have the 4 subintervals. Let us first clear this. So in this method, what we have to do is we have to take interval of x-axis, or we can say time axis. Here its gap is 3. Now this gap is 4. This gap is again 3. This gap is again 2. And what we do, we are taking here right Riemann sum theory. In the right sum theory, we have to take the value of right point. So we have to take this point for this block. For these pair, we have to take this point. For this pair, we have to take this point. For this pair, we have to take this point. So we can write 3 into minus of 5 plus 4 into minus 4.4 plus 3 into minus 3.8 plus 2 into minus 3.5, right? So we have to calculate this. So this will be minus of 15 minus 17.6 minus 11.4 and minus of 7. So after calculating this, we can find minus of 51, and its unit will be centimeter, because it's a area. It will give area. So how we can find area? See, centimeter per day into day. So days cancel out and the unit will get centimeter. So its answer will be minus of 51 centimeter. Let us see its last part, that is the D part. The height of the cone decreases at a rate of 2 centimeter per day. So for D part, we can write dH upon dt is equal to minus of 2 centimeter per day. We have to take care of this minus sign. We have to put it externally. We have to assign this sign externally, because it is decreasing. It is written, it is decreasing. So we have to take care of this sign. Otherwise, answer will be wrong and misleading. At time t is equal to 3 days, at time t is equal to 3 days, the radius is 100 centimeter, height is 50 centimeter. Find the rate of change of volume. So we have to find dv upon dt with respect to time in cubic centimeter per day at t is equal to 3 days. So we have to find this at t is equal to 3 days. So we can calculate this easily. We know the volume of cone is 1 by 3 pi r square into h. Differentiating both sides with respect to time, we will get y 3 and pi will take out, right? So we have to differentiate r square into h. So we can differentiate it r square dh upon dt plus h into 2r dr upon dt. Let us put the values of these. Pi by 3 r square, r is at t is equal to 3, r is 100 centimeter. So we can write it 100 square dh. Let's do the calculation of unit also. So this is the 100, this centimeter square, dh upon dt minus 2 centimeter per day plus h. H is also given. H is basically 50 centimeter. So this is 50 centimeter into 2 into r is 100 centimeter into dr upon dt, basically minus 5 centimeter per day. This will be, so we can see the unit. What is the unit here? Pi by 3. This is minus 2, this centimeter cube per day minus 5, this centimeter cube per day. So the overall answer will be, that is the pi by 3 minus, we will take out common, and this will be 70,000 centimeter cube per day. So this will be dv upon dt at t is equal to 3 day. Okay students, so I hope you have understood this question very well. Thanks.